Hello students, welcome back to Sir Rasayan. In this lecture I am going to explain how to distinguish between following compounds. One by one I will explain. This is Indrani ma'am. If you like, please subscribe. This is chlorocyclohexane, this is chlorobenzene. Now you take two compounds in two separate test tubes. Add in each test tube aqueous KOH and boil. Where chlorocyclohexane is there, by the treatment with aqueous KOH, nucleophilic substitution will take place. You will get cyclohexanol because this carbon is sp3 hybridized. So here nucleophilic substitution is easier. Now in the test tube you add few drops of dilute nitric acid and then silver nitrate solution. What will happen? Neutralization of excess KOH will take place. You will get potassium nitrate and water. Now we are adding AgNO3. So here by nucleophilic substitution Cl is displaced. We are getting KCl. So in the medium we are adding now silver nitrate. So what will happen? Where chlorocyclohexane is there, in that test tube you will get precipitate of AgCl, white PPT, plus KNO3. So the test tube where you are getting white precipitate of AgCl, in that test tube the compound is chlorocyclohexane. But in chlorobenzene, this carbon is sp2 hybridized, and you know, due to resonance, this CCl bond is having some double bond character. So here nucleophilic substitution like this will not take place. So here by the following reaction we will not get any white precipitate. So the test tube, after adding all those things where you are not getting white precipitate, means in that test tube chlorobenzene is there. Next is between ethyl chloride and vinyl chloride. This is ethyl chloride, this is vinyl chloride. Once again you see the carbon where Cl is attached is here sp3 hybridized, and this carbon is sp2 hybridized. So here nucleophilic substitution is possible. Here it is not possible because due to resonance, as I have shown for chlorobenzene, due to resonance CCl bond is having partial double bond character. So it's not easy to break that bond. So here nucleophilic substitution is not possible. So if you treat this compound with aqueous KOH, if you boil it, by nucleophilic substitution we will get ethanol plus KCl. Now in that medium, if first you neutralize with dilute HNO3 and then if you add silver nitrate, what will happen? By the reaction of this and this we will get precipitate of AgCl, white precipitate. But similarly, if you treat vinyl chloride, if you are boiling, then you are adding few drops HNO3 after cooling the solution, and then if you are adding AgNO3, there what will happen? No reaction. You will not get any PPT, no white PPT. So by this chemical reaction you can distinguish between two compounds. See, this is benzyl chloride, this is chlorobenzene. This carbon where Cl is attached is sp3 hybridized. So obviously here nucleophilic substitution will take place. This carbon is sp2 hybridized. So here nucleophilic substitution is not so easy. So if you treat this compound first with aqueous KOH, boil, then if you cool it, then if you add few drops of dilute HNO3 and then silver nitrate, what will happen? White precipitate of AgCl will form. The detailed reaction I have explained already for 1 and 2. And here by similar treatment there is no reaction, no white PPT or no reaction. Next is bromoethane and chloroethane. The carbon where halogen is attached, in both the cases it is sp3 hybridized. So nucleophilic substitution is possible. So if you treat this compound with aqueous KOH, what will happen? You will get, here nucleophilic substitution will take place. You will get ethanol plus KBr. And if you treat similarly, you will get ethanol plus KCl. Now after cooling, if you treat it with nitric acid and silver nitrate, what will happen? You will get precipitate of AgBr, which is yellow PPT. And here if you treat similarly with HNO3 and AgNO3, you will get white precipitate of AgCl. So in both the cases you will get PPT, but here color is yellow, here color is white. Now how to distinguish between terminal alkyne and internal alkyne? Terminal alkyne means here you will get H, but internal means both the side substituents are there. So if you take terminal alkyne, if you treat it with ammoniacal silver nitrate, you will get this is silver acetylide. You will get here white PPT of this. Similarly, if you take this compound, if you treat it with, once again, take this compound, terminal alkyne, if you treat it with ammoniacal cuprous chloride, this is cuprous chloride, ammoniacal means ammonium hydroxide. What will happen? This is acidic hydrogen, so obviously here you will get red precipitate of this copper acetylide. Since here no hydrogen, acidic hydrogens are there, so when you will perform similar reaction, here you will not get any such product because there is no reaction. From here you can put arrow, you can write those reagents, you will get no PPT or no reaction you can write. Now this is isopropyl alcohol, this is primary and this is secondary alcohol. So how to distinguish between two? If you treat these two compounds separately with Lucas reagent, which is equimolecular mixture of concentrated hydrochloric acid and anhydrous zinc chloride, you will get what here? Reactivity of secondary is more than primary alcohol. So here you will get cloudiness within 5 minutes. Because this is secondary alcohol. For primary alcohol, if you treat with this reagent, what will happen? You will get this product, but at room temperature you will not get the product. So after adding this reagent and heating, you will get this compound. So at room temperature, no cloudiness. At room temperature, no cloudiness means no product, because this is less reactive. Primary alcohol is less reactive. But if you heat it, you will get the product. Today till this, thank you for watching.